Hello guys, welcome to another video in the series of coding. Today we are going to do the problem which is called smallest factorial number. Let's take an example. Input is given n equal to 1. The output is 5 because 5 factorial is equal to 120 which has 1 trailing 0, right? So in this case the last digit is 0 which is called a trailing 0. So that's why the output is equal to 5. Let's take another example. N is equal to 6. Now we can see 25 factorial has 6 trailing zeros. So we'll see how it has 6 trailing 0. We'll learn how to do that. But the answer is 25 because 25 factorial has 6 zeros and the input was n equal to 6. Okay, let us write this down. So we are given, for example, n equal to 6. The answer is 25 because supposedly we are given that 25 factorial has 6 trailing zeros or 6 zeros at the end, right? Now let's say the reverse problem was given. Let's say somebody asked us how many zeros are there in 25 factorial. Can we find it out? So it's a simple mathematical problem, right? There's no coding involved in this. Somebody has told us find out the number of zeros in 25 factorial. How are we going to do that? Okay, let us see. So what is 25 factorial? 25 factorial is just 25 into 24 into 23 into 22 and so on multiplied all the way up to 1, right? So if you multiply 1 into 2 into 3 up to 25, we get 25 factorial. This is 25 factorial. Now we have to identify the number of zeros in 25 factorial. How can we identify that, right? So let's take a simpler problem to solve this. Let's say somebody has given us 5 factorial. Can we identify the number of zeros in that? The problem is simpler, right? Because we can write down 5 factorial and see 5 into 4 into 3 into 2 into 1. Okay, how can we identify the number of 0? See, if there has to be a trailing 0 at the end, right, it doesn't matter what digits are there before. For a 0, you need this number to be a multiple of 10, right? Then only it's going to be a 0. So let us see here. Here you have 5 into 2, which is equal to 10. And the remaining number is 4 into 3, which is 12. That is why 5 factorial is equal to 120. So the number of tens you have, right? The number of tens you have, that many zeros you have in the end. Okay, it's as simple as that. Let's take some other example. Okay, let's say somebody asks us to find the number of zeros in 8 factorial. So what is 8 factorial? 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, now what are going to be the number of zeros in this? You still have only one 5. Okay, but you can get many 2's, right? You still have only one 5, but you can take a 2 from here, 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 and so on, right? So you have many 2's, right? So you have many 2's, but you have only one 5, right? So I have written X because there are many more 2's compared to 5, right? How many 2's are there? We get 1 2 from here, we get 2 2's from here, we get 3 2's from here, we get only 1 2 from here. We get 2 2's from here, we get 1 2 from here, we get 3 2's from here. So you have 3 plus 1 4, 4 plus 2 6, 6 plus 1 7. So you have 5 into 2 power 7 into 7 into 3. So this number 8 factorial is actually equal to this. Now this doesn't matter, this doesn't matter, this doesn't matter, this doesn't matter. What matters is only the number of 5's you have, because everything else, even if you have that, but if you don't have 5, that means you cannot make a 10. 5 is the limiting number, right? The number of 5's you have, that many numbers of 10 you have. Why? Because 2 is in abundance, right? 2, let me write it. 2 is in abundance. It doesn't matter. The number of 2's are always going to be greater than the number of 5's, right? So in any example you take, only the number of 5's will be limiting. So the number of 10's or the number of zeros that you have is going to be just determined by the number of 5 you have. So that many 5 you have, that many zeros you have. Now we know it's very simple. We need not calculate 8 factorial to check the number of zeros. We just know we have one 5. So we will only have one 0 at the end, and in between and before we may have as many numbers as we want, but we will have only one 0 because there's only one 5 and you need that 5 to make up a 0, right? So now let's calculate for some other number. Let's say somebody asks you to find the number of zeros in 25 factorial. How will you calculate? So we know we have to just calculate the number of 5, right? It's a simple mathematical problem. How can we calculate the number of 5? Okay, let's start with some logic. Okay, so let's see what are the multiples of 5 that we have. From them we can extract 5, right? So let's say we have 5. In this series, we will have 5 somewhere, right? Here somewhere we will have 5. Okay, so we will have a 5, we will have a 10, we will have a 15, we will have a 20, we will have a 25. Now these are all the multiples of 5 and these will be the number of 5's that you have, right? So from this you can extract 1 5, right? From this again you can extract 1 5. From this again you get a 1 5. From this again you get 1 5, right? Because it's 5 into 4, so you can take out the 5 from that and so on, right? But from this you can get 2 5s, right? So the total number of 5s that you have is actually, you have 1 from here, 1 from here, 1 from here, 1 from here, but 2 from here. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 2 is 6. So 25 factorial has 6 zeros, right? 25 factorial has 6 zeros. Okay, now let's take some other example. Let's say somebody asks us to find the number of zeros. Let's take a big number, okay? Let's say somebody asks us to find the number of zeros in, let's say, 140 factorial. How are we going to find out? So what is 140 factorial? 140 into 139 into 138 all the way up to 1, okay? So what we have to do, we have to just calculate the number of 5s that we have in this entire factorial, right? So how can we do that? We need not write out the entire series and then keep on counting the 5. Let's try to get smart, right? So first of all the multiples of 5, right? 5, 10, 15, 20, 25, all the way up to 140, we will be able to extract from those. We will be able to get a 5 each, right? So from this we'll be able to get 1 5, from this again 1 5, from this 1 5, from this 1 5, from this we'll be able to get 2 5s. But let's just consider at least we'll be able to get 1 5 from all the multiples of 5, right? At least 1 5, okay? So let's just see the multiples of 5 for now. How many multiples of 5 are there? Now see, this is the first multiple of 5, this is the second multiple of 5, this is the third multiple of 5, this is the fourth multiple of 5, and so on. How many multiples are there? We have 140, right? So if you divide 140 by 5, what do you get? 5 2s are 10, and then you have 8. You have, this is 28th multiple of 5. So the number of 5s you have is at least 28. Why am I saying at least 28? Because we have 28 5s that we know for sure. But from numbers like 25, you have 2 5s, right? So, okay. So now we will consider those cases, okay? At least we have 28 number of 5s, okay? Now let's consider multiples of 25. These were the multiples of 5. Now let's consider multiples of 25, from which we can extract other 5s. So the multiples of 25 are 25, 50, then you have 75, then you have 100, and so on, right? Up to which number it will be? Up to 125 it will be, right? 125 will be the last multiple of 25 before 140. So how many multiples of 25 you have? Again, you need not check, right? Again, you need not write down all the multiples and check. What you can do is you can just divide 140. Just divide 140 by 25. When you divide that, you get, what do you get? If you round it off, you get 5, right? So in this case, you know that you have 5 multiples, right? Because 1, 2, 3, 4, 5. These are all the 5 multiples of 25. Now from each of those, you can get 2 5s, right? From each of those you can get 2 5, okay? For example, what is 100? 100 is just 25 into 4. So this is 5 square into 4. So from this you can get 2 5, right? So from each of them you can get 2 5s. But you have already considered 1 5 in the previous case. When you took 28 5s, right? Already 1 5 you took. Already 1 5 was counted here, right? Already 1 5 was counted here. So you just have 1 extra 5. Now 1 5 which you did not count, that you can write here, right? So from all this you can get that 1 5 which you have not counted. Okay. Now is it over? It's not over, because now you have 125 also, right? 125 is 5 cube. This was 5 square. This is 5 power 1. Okay, now you have 125. In 125 is actually 5 power 3. But for 125, if you think, you have only calculated 1 5 and you have calculated 1 5 here. But 125 is actually 5 power 3. So 1 extra 5 you have to calculate again. So this is the simple logic. So what is the total number of 5s? First let's calculate that. Here you have 28. Here you have 5. And here you have 1, right? So the total number of 5s in this is 28 plus 5, 33. 33 plus 1 is 34. So if somebody asks me in 140 factorial, how many zeros are there? That is just equal to the number of 10s. And the number of 10s is limited by the number of 5s. Because 2 is in abundance. 2, we just have a lot of 2s. Only 5 is the limiting factor. So if we calculate the number of 5s, we can get the number of trailing zeros. And what is that? In our case, the answer is 34. Okay, let's quickly take another example and then we will just move forward to how to solve this problem, right? So let's say, quickly let's just do it now. Somebody asks us how many 5s are going to be there sorry, how many zeros are going to be there in 200 factorial, let's say. Okay, so the problem is very simple. We have to just calculate the number of 5s in this 200 factorial. Okay, so how do we calculate that? Now it's very simple. First of all, we'll calculate how many multiples of 5 are going to be there, right? So it's very easy. First, just divide 200 by 5. So we have 40 multiples of 5. Okay, so we have at least 40 zeros. Now you have to count how many multiples of 25 are there up to 200, because those are the extra number of 5s which you did not include in this case, right? For example, in cases like 25, in cases like 100, in cases like 75 and so on, right? In all these cases you have 5 power 2, but you only included 5 because you just took one time, you just took 1 5 only. So the remaining you have to take by adding this quantity, right? So as we discussed in the last logic, let me not complicate it. We have already discussed this logic, right? So now we have also to count the number of multiples of 25 for calculating the remaining 5s which we forgot to add previously, right? So now how many extra 5s we have? So this is 8, I guess. Okay, now let us again divide 200 by 125. These will be the extra 5s which we did not include in these two quantities, right? So in cases like 125 is actually 5 power 3, right? But you have only taken 2 5s. You should actually take 3 5s, right? So that's why we need to divide by this and find out how many multiples of 125 are there. Okay, so what is this? This is just equal to 1, right? If you take the value, it will be just 1. So after this, if you take 5 power 4, after this everything you are just going to get 0. So you need not include these cases. So what is the final answer? 40 plus 8 plus 1, which is equal to 49. So in this case the answer is 49. Okay, so now we have understood how to first of all calculate the number of zeros in any factorial, right? So that is simple. Okay, now let us see how to solve this problem. Okay, so let us say somebody gave us n equal to 6. Okay, now we have to find which number. Okay, let that number be x. So the x factorial should contain 6 zeros, right? X factorial should contain 6 zeros. We should find such a x. This is our problem. We should return x. Now how do we solve this problem? Okay, so let us start from the very beginning. What is our low value? The lowest number which we can start from, let's say we start from 0. Now what is our high value? Okay, let us consider. See, how do you calculate the number of zeros for any number? We have a number x, we want to find the number of trailing zeros in its factorial. So what we are doing, we are just dividing x by 5, then we are dividing x by 25, then we are dividing x by 125 and so on, right? We keep on doing this and the answer that we get, right? The answer that we get should be equal to 6, because that number should have 6 zeros. Okay, it's given in the question. This is the input value is given 6. Now how do we solve this equation? Okay, if we are able to solve this equation, we get our answer for x. Okay, now we have to try to find out what is the x. Okay, we don't know till how many terms we should keep on including this. Okay, so what we will do, see, at least see what we will do, we don't know how many terms we have to add. So what we know, see, let's say if I remove these terms, right? If I remove these terms, that means x by 5 will be less than equal to 6, because I am removing some positive terms. These terms are all positive. So x is less than equal to 30. This is my limit for x. So x should definitely be within 30. See, I am not considering these terms. I am just taking the first term. So because of which x by 5 should be less than equal to 6. So x should be less than equal to 30. So this is my limit for the high value. So my low value is 0. My high value is equal to 30. Okay. So what I am going to do, I am going to try to find the answer for n equal to 6. I know the limit is 0, high is 30. So I will try and check if my mid value is my answer. So I will take mid equal to 15. Now for 15, let me quickly calculate. Okay, let me quickly calculate how many zeros are there in 15 factorial. How can we calculate? Very simple. 15 by 5 plus 15 by 25 plus 15 by 125 and so on, right? So after this you can see terms will become 0. So the answer is just equal to this. Even this is equal to 0. So the answer is just equal to 3. So we can easily see in 15 factorial we have 3 zeros, right? So we know in 15 factorial we have 3 zeros. But how many zeros we want? We want 6 zeros, right? Because n is equal to 6. So the answer cannot be in any value less than equal to 15, right? Because a value smaller than 15 will give even less number of zeros. A value smaller than 15 will have even less number of 5s and even less number of 2s, so even less number of 10s. Okay, so any value from low to mid cannot be the answer, because 15 itself is not the answer. 15 has only 3 zeros, but we need 6 zeros. So any value greater than 15 is only the answer, right? So now we have again found out one thing. We know that our low value is 16 and our high value is equal to 30. Within this we have to find the answer. So what is my mid value? Mid value is 16 plus 30 by 2, right? So what is that? 46 by 2. So we will try for mid equal to 23. Let's see how many zeros are there in 23 factorial. How can we find out? Very easily we can find out. It's just 23 by 5 plus 23 by 25. This is also 0, so we can stop. So it's just 23 by 5. So what is 23 by 5? It is just equal to 4, right? So and now let me write it again. In 23 factorial we have 4 zeros. But how many zeros do we want? We want 6 zeros, right? So still we have less number of zeros. So any value from 15 to 23 also cannot be the answer, because all the values less than 23 factorial will have even lesser number of zeros, right? So again our low and high changes. So low is at least 24 and high is 30. Again let's calculate the mid value, right? What is the mid value? 24 plus 30 is equal to 54. 54 by 2 is equal to 27, right? It is equal to 27. Now let's calculate in 27 how many. In 27 factorial, how many zeros we have? Very easy, very simple to calculate. Just calculate the number of 5s, right? So once you do this, after this, if you take all these values will become 0. So from this you just have 1. From this you have 5. So the number of zeros is 6. Okay, but is 27 the answer? So now let's notice carefully. So what we did, we found out 27 factorial has 6 zeros. But we have to find the minimum such answer. It is not necessary that 27 is the answer. But we know any number at least 27 and any number greater than equal to 27, all those factorials will have 6 zeros, right? But we need the minimum answer, okay? But we need the minimum answer. So 27 we can store in answer. We can say 27 is our answer. But we can try finding out even a better answer. If we are able to find a better answer, even great for us, okay? So what we did in the previous case, we saw low was equal to 24, right? So our answer is anywhere between that low value. Low will remain as 24, okay? Now we will change our high to 27 minus 1, which is equal to 26, right? So now we will try for a better answer. So what is mid? Mid will be 25, okay? Now let's try to find the minimum possible answer. At least 27 is our answer, but let's try to see if on the left side of 27 can we get a better answer. If we can get a better answer, we will change our answer, okay? We want to find the minimum such answer, okay? So that's why I have let the low remain as same, but I have changed the high to 27 minus 1, which is 26. So mid is 25. Now let's find the number of zeros in 25 factorial. So it's equal to 25 by 5 plus 25 by 25. After this, everything will give 0, right? So this is 5, this is 1. So 5 plus 1 is equal to 6. Again, you can see 25 factorial also has 6 zeros. So now we will change our answer variable and our answer will become 25. 25 is our answer for now, okay? Now again we will change the values. Now let us try to find out our answer in less than 25. So we will change our high to 24, low is also 24, so mid will be 24. This will be our last iteration, by the way. After this we will exit because it will go out of bounds, right? So let's see, mid is 24. So let's try to find the number of zeros in 24. This is 0, this is 5. So we have 5 zeros. So this is not the answer because we need 6 zeros, but we have only 5 zeros, right? So 24 is not the answer. So we'll try looking for an answer, better answer. So we'll change our low. Low will become equal to 25. High will become equal to 24. Low is greater than high. From this we can exit the binary search. So what we are doing, we are basically doing a binary search. That's all we are doing, right? So now let's code it. It's simple only. It may look complicated, but it's actually very simple. So what is low? Low is equal to 0. Okay, we are starting from 0. What is high? High is equal to 5 into n, because we just saw in our example, for example, high was 30, right? Because our n is equal to 6. So high was equal to 30 in the logic which we just discussed. Let's just apply the simple binary search. While low is, we can give less than equal to high. We can have an answer variable which is going to store our answer. Okay, so initially you can give answer equal to low, let's say. For example, we are starting. Now let's calculate the mid. Mid is nothing but low plus high by 2, right? As usual. Now we have to give a function which is going to check the number of zeros in the factorial, right? So let me give the function find number of zeros in the factorial of the number, right? In factorial of the number. This is my function and I'm going to pass my mid value in this, okay? and whatever answer this function returns, okay, let's say I am storing that as zeros. This is going to find the number of zeros in the factorial of that number. Okay, so we are going to write that function, but first let's complete the binary search. Now the number of zeros that it received, okay, if for example it is greater than equal to n, then it's awesome for us, right? We have found our answer. Okay, the number of zeros should be greater than equal to the given condition, which is n. At least we need 6 zeros in the answer, right? So in that case we have found our answer. Answer is equal to mid, but we will try to find a better answer. So we need the minimum answer, right? So what we will do, we'll try to find a better lower answer. So how can we find that? So we can just move our high, and high will be equal to mid minus 1. Okay, else if we have not yet found our answer, then we have to keep continuing and we have to increase our value so that we get more number of 5s, more number of 2s, more number of 10s, more number of zeros, right? So in this case we will increase. After all this is done, we can just return answer. Okay, that's it. Now I have to just declare this function, and this function is very simple. It will just count the number of zeros in factorial. So let's declare this function. It's of type int. Okay, it takes some input. Let's say it takes input x. So what are we doing? We are just in this function, we have to basically just return x by 5 plus x by 25 plus x by 125 and so on, right? So this is what we have to actually return. So let me just give a loop while x. So we are starting from, okay, so we have to give x by 5 plus x by 25 and so on, right? Plus x by 125. The value of this entire expression is what we have to return, right? So let me just give, initially we are starting with 5 as the denominator, right? So let me just give denominator. So denominator is going to, let me just give denom for denominator. Denominator is just going to start with 5, right? So while x is greater than denominator, what we can do, because after this it will become 0. Okay, so what we have to do, we have to just calculate the number of zeros, right? So let me call it 0 initially. So the number of zeros we can just add, we can just divide x by denominator. That's it. That's what we are doing. Now what we can do, we can change the denominator. Every time we can multiply the denominator by 5. So initially in this first iteration we are dividing x by 5. Next time we are multiplying the denominator by 5, so it becomes 25. So next time we are dividing x by 25 and we are adding that to the answer and so on. So we'll keep on doing this till x is greater than denominator, after which it becomes 0. There is no point in adding 0 to the answer, right? Answer will still remain the same. So we can just return zeros. That's it. This is the simple logic. Now let me compile and see if it's working. So it's working. Let's submit and see if it's working for all the given test cases. So it's working. Thank you for being patient and listening.